All right, let's go ahead and start talking about this warm-up. Number 3, the first thing they want me to find is segment AB, this segment right over here. How big would segment AB be? 6.9. We have a congruence marking on AB and BC. So AB would be 6.9. Then they want us to find the measurement of angle BDA. BDA. So we are looking for this angle right here. How big would angle BDA be? It is 30 degrees. Yes, that angle is congruent to BDC. So BDA would be 30 degrees. That long diagonal is bisecting the top and bottom angles here. All right, on number 4, we need to find the measurement of segment EH. How big would segment EH be? 3.7. We have a congruence mark on EH and a matching congruence mark on GH. So EH would be 3.7. And then we need to find the measurement of angle EJF. E to J and then up to F. So we are looking for this angle right here. 90 degrees, yes, because these are kites. Those diagonals are perpendicular to each other, so it is forming a 90-degree angle for all 4 of those angles. So the measurement of angle EJF is 90 degrees. Nice work. All right, the rest of our time together today, I want to spend answering any questions you guys have off of the test review that you received on Friday. If you don't have a copy of the test review, it is the second paper up from the bottom in the red organizer hanging on the board over here. So go ahead and pull out your reviews. Take a moment to look through those. And let me know what problems you would like to see me work through. Yes. Number 11, absolutely. We have a quadrilateral ABCD, and they tell me that it is a rectangle. So there's a whole bunch of information that I know by understanding that this is a rectangle. I know that all 4 corners are right angles. So I'm going to go ahead and mark that on my picture. I know that opposite sides are parallel and congruent. So AB and CD are parallel and congruent. BC and AD are parallel and congruent. And then I also know that in addition to those diagonals bisecting each other, those diagonals are also congruent to each other. So BE is the same size as DE, but it's also the same size as AE and CE. All 4 of those little half diagonals are congruent because it's a rectangle. They tell me that BC is 12, so I'm going to add that to my picture. Well, if BC is 12, what else is 12? AD is also 12, so I can go ahead and add that. Tells me that AB is 8. Well, if AB is 8, what other side is 8? CD. And then they tell me that the measurement of angle BEA is 48 degrees. BEA. So this angle right here is 48 degrees. Using that information, we are supposed to find A through H over here on the left. So let's start in on that. Measurement of angle ABD. ABD. So they want me to find this angle right here. Well, I'm looking at this triangle right here. And I notice that two of those sides are congruent. BE and AE are congruent. So that makes this an isosceles triangle. That means my base angles, ABD and BAC, are congruent to each other. So I'm going to call both of those X. So those are the three vertices of a triangle. So I can do X plus 48 degrees is equal to 180 degrees. So I'm going to combine these two together, and I'm going to subtract 48 from both sides. So it cancels out on the left. On the left, I still have X plus X, so that would be 2X equals, and then 180 minus 48 is 132 degrees. Then we're going to divide both sides by 2. And I get that X is 66 degrees. And X was standing in for the measurement of angle ABD. So ABD is 66 degrees. So I'm going to come back to my picture, and I'm going to put that in for these two angles. This is 66 degrees. And this angle down here is 66 degrees. Next thing they want me to find is the measurement of angle AED. So this angle right here. Well, I know that that angle and the 48 degrees, the measurement of angle BEA, those are supplementary angles. So I know that together they're going to add up to 180 degrees. So I can say 48 degrees plus the measurement of angle AED equals 180 degrees. So then I subtract 48 from both sides. The measurement of angle AED is 132 degrees. So I'm going to add that to my picture as well. 132 degrees right here. EAD. Now we want EAD. We want this angle right here. There's a couple ways I could go about finding this. This is also an isosceles triangle down here. So I could do it just like I found ABD. I could do X plus 132 degrees equals 180. Or, because now I know how big BAC is, I know that's 66 degrees, these two angles put together would have to add up to what? Has to add up to 90 because this is a rectangle and it's 4 right angles in the corner. So I can say 66 degrees plus the measurement of angle EAD is equal to 90 degrees. I can subtract 66 degrees from both sides. That means the measurement of angle EAD is 24 degrees. All right, now we have angle BDC. Angle BDC is this angle right here. And we should already know how big that angle is without having to do any extra work. This angle right here, 66 degrees. These two angles right here are congruent to these two angles right here because this little triangle on the left is congruent to this triangle on the right. We have vertical angles and we have congruent sides, so we can use side angle side to say that those two triangles are congruent. Yes?
So it would be wrong to assume that the angles bisect?
Yes, on a rectangle, the diagonals are bisected, but the angles are not. On a square and on a rhombus, the angles are bisected. And on a kite, that long diagonal is bisecting the angles. But those are the only three shapes where we have angles bisected. So in a rhombus, both pairs of angles get bisected by their diagonals. In a square, both pairs of angles get bisected. And in a kite, one pair gets bisected, just from the long diagonal. Good questions. All right, so this is 66 degrees. Two more angles to go. DCB is next. Oops. DCB. Here's DCB. So this angle right here, how big is that angle? 90 degrees. Last angle now, BCE. BCE. This angle right here. 24 degrees, yes. I forgot to add the 24 to our picture down here earlier. But this upper isosceles triangle, BEC, is congruent to this lower isosceles triangle, AED. So that means that BCE is 24 degrees, just like angle EAD. All right. Next thing they want me to find is the measurement of angle angle BD. I want segment BD. So from right here to right here. I'm going to have to use Pythagorean theorem to help me do that. A squared plus B squared equals C squared. And I'm looking at this right triangle right here. This is why I'm using Pythagorean theorem, because half of the rectangle is what I would have if I trace over that diagonal BD. Because all four corners are right angles, when I cut it in half like this, I end up with a right triangle. And because they told me how big BC is, and AB is congruent to CD, I know the two legs of that right triangle. So I would have 12 squared plus 8 squared is equal to BD squared. 12 squared is 144. 8 squared is 64. 144 plus 64 is 208. So 208 equals BD squared. And then we do the square root of both sides to isolate BD. Squared and square root cancel each other out. And the square root of 208 is approximately 14.422. If I know that BD is 14.422, how can I then use that to figure out how big AE is? Divide it by 2. Yes, BD and AC are congruent. So that means the measurement of AC and the measurement of BD are the same. AC is 2 times AE. Because here it's AE and another AE. These two are congruent. So 2 AEs put together gives me the same length as BD, which is 14.422. And then we divide both sides by 2. When I divide 14.422 by 2, I get 7.211. What else would you guys like to see from the review? What other problems would you like me to go over? You have one? Please go ahead and pull it out then. Oh, just use another one then. That's fine. Yes. Number 1? Absolutely. Number 1, we're supposed to find the sum of the interior angles, and then we're going to use that to find the measurement of angle B. And in the process, we're going to have to find x. So for the sum of the interior angles, we do n minus 2, and we multiply that by 180. What does n represent here? The sides. How many sides does this figure have? Let's count them up. So I got 1, 2, 3, 4, 5, 6 sides. So we do 6 minus 2 times 180, or that would be 4 times 180. And that is 720 degrees. We need to find x so that we can find the measurement of angle B. Well, the sum of all 6 of those angles is 720 degrees. So I can add those angles together. Measurement of angle A plus the measurement of angle B plus the measurement of angles C, D, and E. And measurement of angle F. And that is equal to 720 degrees. So now we start substituting in. How big is angle A? 90. So I put 90 in here for the measurement of angle A. Angle B is 2x plus 18. Angle C is 3x plus 2. Angle D is 151 degrees. Angle E is just x degrees. And angle F is 108 degrees. So we add all of those together and set it equal to 720. Then we need to combine our like terms together. So here's 2x. 3 more would be 5x. And this one, so I have 6 x's altogether. And then I need to combine my constants together. So I have 90 plus 18, that would be 108, plus 151, so 259, plus 108, so 367, I think. Can somebody double check me? I'm adding it in my head here. 369, okay. Like I said, I'm adding in my head. 369, there we go. Then we subtract 369 from both sides. What is 720 minus 369? 351. And we divide both sides by 6. We get a decimal, but it's not too bad. What do we get for x? 58.5. Now we're going to use that to find the measurement of angle B. Measurement of angle B is 2x plus 18. We just found that x is 58.5. So 2 times 58.5 plus 18. 2 times 58.5 is 117 plus 18. I get 135 degrees. Yes. Number 6, part B, absolutely. First thing they tell me about this shape is that it is a rhombus. So I'm going to mark up all the information that I know about a rhombus before I start trying to answer any questions. A rhombus has 4 congruent sides. The angles are bisecting each other, so MN is congruent to CN, and DN is congruent to RN. Where those diagonals cross each other, it forms 4 right angles. And then those diagonals are bisecting those angles. So MDN is congruent to CDN, is congruent to MRN, is congruent to CRN. And DMN is congruent to RMN, is congruent to DCN, is congruent to RCN. And I have a little bit more information here. I have that this angle is 18 degrees, so all those other angles that get marked with the same congruence marks, CDN, MRN, and CRN, these are all 18 degrees. So all 4 of those angles are 18 degrees. It tells me that MD is 20, they have that marked for me already, and that MC is 24. Well, MC is this entire diagonal. And what's happening to that diagonal? Right in the center, what's happening to it? It's cut in half. So if the whole thing is 24, how big is each half? 12. So MN is 12, and CN is also 12. All right, let's see if we can answer the questions now about these different measurements. We want the measurement of angle RNC. RNC. How big is that angle right there? 90 degrees. Then angle DRC. DRC, this angle right here. How big is that angle? 18 degrees. Remember, that's congruent to MDR. Those 4 angles are all 18 degrees. Angle NMR. NMR. This angle right here. Well, to find that angle, I'm looking at this triangle right here. Because I know that the angles of a triangle always add up to how much? Always adds up to 180. I know one of those angles is 90 degrees. I know one of those angles is 18 degrees. And then there's angle NMR. So those three angles all added together is going to add up to 180 degrees. So I'm going to set that equal to 180. I add the 90 and the 18 together. That gives me 108 degrees. And then I subtract 108 from both sides. So the measurement of angle NMR is equal to 72 degrees. That is not the only way to find that angle, by the way. That is one way to find that angle. Well, if that angle right up there is 72 degrees, how big is angle DMN, this one right here? If RMN is 72 degrees, this angle right here is 72. How big is angle DMN, this angle right here? 72. What about these two angles at the bottom, DCN and RCN? How big is each of those? Each of those are 72. Which helps me answer this next question. They want to know the measurement of angle DCR. This angle right here. How would I find the measurement of that whole angle? Add 72 and 72, or you could multiply 72 times 2. 72 plus 72 is 144. So 144 degrees for the measurement of angle DCR. All right. They want me now to find the measurement of segment DN, this segment right here. So once again, I'm looking at a right triangle. I'm looking at this right triangle here. Because I know how big this side is, that's 20. I know this side over here is 12. And it is a right triangle, so I can use the Pythagorean theorem to help me figure that out. A squared plus b squared equals c squared. For this triangle that I have highlighted in yellow, 20 is opposite that right angle, so that is my hypotenuse, so that goes in for C. 12 goes in for either A or B, doesn't matter. So I have 12 squared plus dn squared is equal to 20 squared. 12 squared is 144. 20 squared is 400. So then I subtract 144 from both sides. I get dn squared is equal to, what is 400 minus 144? $256. And then we do the square root of both sides to get dn isolated. Over on the left, the squared and the square root cancel each other out. What is the square root of 256? 16. So dn is 16. And then the last thing we need to find is segment dr, which would be this entire diagonal. We just figured out that dn is 16, so how big would rn be? It's also going to be 16, right? For rn. So 16 and 16, so to find dr, I'm going to take 16 times 2, or 16 plus 16. That would give me 32. We have 10 minutes left. That's enough time for one long question or two short questions. Yes. Number 5? Absolutely. For number 5, we need to find YAB, measurement of angle I, and the length of GJ. So let's find Y first. I know this is a parallelogram, so I'm going to mark it up with the information that I have. In a parallelogram, opposite sides are congruent, and opposite angles are congruent. So GH is congruent to JI. So that means that segment GH is equal to segment JI. GH is 2y plus 2. JI is 3y minus 9. Now I want to get my y's to the same side, so I'm going to subtract 2y from both sides. That gives me 2 is equal to 3y minus 2y is 1y, so 2 equals y minus 9. And then we add 9 to both sides to isolate y, and I get that y is 11. And then we come over here to A. There's only one angle that has A in it. It's right here, angle I. What do I know about angles I and J? They equal to 180. Those are supplementary angles. We have consecutive angles, and so they are supplementary. So the measurement of angle I plus the measurement of angle J is equal to 180 degrees. Angle I is 4A minus 21. Angle J is 81 degrees. And that's equal to 180. We combine our constants together over on the left, combine our like terms. Negative 21 and 81 gives me 60. Then I subtract 60 from both sides. 180 minus 60 is 120. So I have 4A equals 120. Then we divide both sides by 4. And I get that A is 30. To find B, that's here with angle H. What kind of a relationship can I make between angle H and some other angle? I need a relationship between angle H and some other angle so that I can find this. It's congruent with, not with I, but with which one? J. Angle H and angle J are congruent to each other. It's confusing having G and J. I always mix those two up when I'm saying them. So angle H is congruent to angle J. So the measurement of angle H is equal to the measurement of angle J. Angle H is B plus 78. Angle J is 81. So then I subtract 78 from both sides. And that means that B is 3. All right, we still need to find the measurements of angle I and the measurement of segment GJ. Well, measurement of angle I, 4A minus 21. And we figured out earlier that A was how big? 30. So I have 4 times 30 minus 21. 4 times 30 is 120. 120 minus 21 is 99. So the measurement of angle I is 99 degrees. And then how can I figure out the size of GJ? GJ is the same size as what? HI. So GJ is congruent to HI. That means the measurement of segment GJ is equal to the measurement of HI. And how big is HI? Y plus 4. And we figured out that Y is how big? 11. So I have 11 plus 4. And 11 plus 4 is 15. So segment GJ has a length of 15. We still have 5 minutes left, so I have time for one short question if you guys want to go over a short one. $14? Absolutely. Number 14. Determine if the following statements are true or false. Circle the true statements. Some parallelograms are trapezoids. That is false. All squares are rhombi. That is true. To be a rhombus, you have to be a parallelogram with 4 congruent sides, and a square is a parallelogram with 4 congruent sides. It also has 4 right angles, but it meets the definition for a rhombus. Some rectangles are squares. That is true. To be a rectangle, you have to be a parallelogram with 4 right angles. Some of those rectangles with 4 right angles also have 4 congruent sides. Not all of them do, but some of them do. Quadrilaterals are never hexagons. That is true. Quadrilaterals have 4 sides, hexagons have 6. So a quadrilateral will never be a hexagon. Squares are always polygons. That is also true. The bases of an isosceles trapezoid are congruent. This is false. It's not the bases that are congruent, it is the legs. All right. The bases are parallel, yes. Bases are parallel, legs are congruent, but only if it's an isosceles trapezoid. The bases are parallel no matter what kind of trapezoid. The legs are congruent because it's isosceles. If it wasn't an isosceles trapezoid, then the legs would not be congruent. Just the bases would be parallel. All right, I'm going to show you guys where you can find the answer key for this. Don't forget, you'll be turning in your review tomorrow. So I'm going to go ahead and stop our recording so that I can show you in Canvas. You go to Modules, you go to today's date. You have to click on the page for today, and that is where you will find the answer key.